The question is about locating the center of gravity for the area shown in figure with respect to coordinate axis. All the dimensions are given in millimeters. So the lamina is formed by joining all the rectangles if you read the figure properly. So now let's try to get the values of area and centroidal coordinates for each of the areas. So area number 1 is a rectangle whose width is 10 mm and height is 30 mm. This total height is 30 mm. Area number 2 is having length of 40 mm and height of 10 mm. Area number 4 is a square. Area number 3 is a rectangle whose width is 10 mm and height is 50 minus 30, that is 20. So centroid for this lamina needs to be computed. So let's begin the process of calculating the areas. Area number 1 is 30 into 10, which is 300 mm square, and centroidal coordinates for area number 1 will be, that is x1 would be 10 by 2, which is 5 mm, and y would be equal to the distance from point O up till here, which is 30 by 2, and that is 15 mm. Next is area number 2, which is having length of 40 mm and height of 10, which is 400 mm square. So x bar for area number 2 will be equal to the distance from the y-axis needs to be measured. So the area number 2 is starting from here. So this additional distance of 10 mm should be added, and that has to be divided with, or that has to be added to the centroid of, or half of the length of area 2, that is 40 by 2. So how far is the area number 2 from the coordinate axis? So if you observe here, this distance of 10 mm should be added directly, and the length is 40 mm and the centroid will be at a distance of 20 from the face, one of the faces of rectangle. But if you measure it from point O, it will be 20 plus 40 by 2, which is 30 mm. Same way for y2, it will be taken as 10 by 2, that is 5 mm. So the centroidal coordinates for area 2 is known. Now area number 3, the height is 20 and width is 10. This will be 200 mm square. And next would be the x coordinate. X coordinate x3 will be 5 mm. There is no change in that, but y3 will be in the downward direction or below point O, which is negative y-axis. So for that case, the y coordinate will be 20 by 2, or I should write it as minus 20 by 2, which is minus 10 mm. Next we have area number 4, that would be 10 into 10, which is 100 mm square. And for area number 4, let me tell you that this would be centroidal coordinate, and the distance from the y-axis would be, this distance is 10 and this distance would be 40. So for area number 4, the x4 coordinate will be 10 plus 40 plus the midpoint of area 4 along the x direction, that would be 10 by 2. So this comes out to be as 55 mm, and y4 will be equal to 10 plus 10 by 2, which is 15 mm. Now, after the coordinates of individual areas have been calculated, next is the computation of centroidal coordinate of the plane lamina, that is given by x bar equal to a1 x1 plus a2 x2 plus a3 x3 plus a4 x4 whole divided by a1 plus a2 plus a3 plus a4, and this is equal to, so a will be equal to a1 is 300 and x1 is 5 mm. Next is a2, which is 400 and x2 is 30 mm. Next is a3 is 200 and x3 is 5. a4 is 100 and x4 is 55 whole divided by a1 is 300 plus 400 plus 200 plus 100. So this, upon solving, we get the answer as equal to 19 mm. Now let's calculate y bar as well, that is a1 y1 plus a2 y2 plus a3 y3 plus a4 y4 whole divided by a1 plus a2 plus a3 plus a4, and this is equal to 300 into y coordinate, or y1 is 15 mm plus y2 is a2 is 400 and y2 is 5, a3 is 200 and y3 is minus 10 mm. Next is a4, that is 100 mm, and y4 is 15 mm. So only area number 3 is having negative y coordinate, no negative x coordinate, as the area 3 is taken in the fourth quadrant and this is taken as an origin. So now this is divided with summation of all the areas, which is 300 plus 400 plus 200 plus 100, and this would be equal to 6 mm. So this is how the centroidal coordinates can be located for a plane lamina which was consisting of only rectangular cross sections.